see the pointer also. I have put it here. So, morning, ladies and gentlemen. I'm Chandrasekaran from NMAS Androids. Good to have you here. Thanks a lot for attending a session and showing interest. I was given to understand from IPTA the target audience will be non-technical or non-associated people in chemical recovery, but some of the team here are known to me. They are very much associated in recovery. So, I will try to go as easy as possible for people who are first time into this basics of chemical recovery. That is the topic I am trying to take. So, you are able to see chemical recovery island within a pulp mill. So, we will be dealing all this area which is vital. We will talk about what is that in the slides to come. Now, chemical recovery mission, the term you might have heard because many of you would be associated in pulp and paper industry, but may not be knowing what is chemical recovery in particular. So, the mission is environmental impact, because when you make the pulp, there is a chemical which is drawn from the cellulose fiber, which is wood or agro material, which otherwise is let into effluent. So, this is very important. You can note down. So, this is basically some 100, 120 years back, it was effluent, where there was no technology to recover the chemical in a pulp and paper industry environment. So, that is where the technology started. The chemical that we are talking is black liquor, or more technical term, it is sodium lignates. So, people who want to note, you can note, but you will have I think the information thereafter you can go through deeply. So, this is chemical recovery called black liquor, which is the spent liquor, which is otherwise goes into the effluent. So, the very existence of this chemical recovery as a technology is to recover this chemical which goes into effluent and then back to the digester or the cooking operation from where the pulp is made, and thereafter is used for paper making or whatever the requirement. So, because we are letting into environment is a pollution, it goes into the effluent. So, this is environmental impact it creates. So, that is we are first mitigating. So, that is one of prime importance. That is how it was started. Then lot of costly chemical, this is sodium hydroxide. So, sodium hydroxide is very costly, as the mill operation team will be knowing. Chemical recovery is very, very important in this. So, that is chemical recycling. And then, by the way, through the process of this chemical recovery, we are able to generate steam. So, that is energy generation. So, 3 points please remember, is very, very easy to understand. So, you are able to see a mill, one of a modern mill, how it looks, having the chemical recovery boiler you are able to see, and then the recovery part of it, recovery boiler is a constituent in the chemical recovery process. So how it starts? Uh, we have evaporation, which is this black liquor which is coming or let into effluent, which is now taken for recovery process, is having lot of water. So that which is having lot of water is very difficult to use it in the boiler process. So we have to evaporate the water. So that is the first process, evaporation, to a desirable extent where recovery boiler combustion is possible. So recovery boiler is the next one. In the recovery boiler, you are recovering the chemical. Basically, I might have given here this reduction reaction, etc. There are basically two processes just for you to note broadly, which is soda process and Kraft process. Soda process is not involving any salt cake or sodium sulfate specifically. Kraft is widely used process because it is very good for paper. So this is two important aspects you can keep in mind. And then the green liquor production is there. Then recausticizing converts the green liquor into white liquor by adding lime. So there is a lime cycle here because the sodium carbonate which is produced in recausticizing is converted back to sodium, that is calcium oxide, by adding lime. So there is a cycle within cycle. This is very important to understand also. Chemical recovery is a broad cycle, then there is a cycle within this. So these two, recausticizing and lime kiln, is together called as white liquor plant. You can keep it in mind. So the four process, easy to understand, is concentration, as I told, removing the water to the desirable extent. So that is evaporation. And the combustion, it is all four C's, easy to remember again. So it is combustion is the in the recovery boiler process, how this black liquor is fired and combusted to get the chemical. Then causticizing completes the recovery of sodium hydroxide. So that is called recausticizing. So you will always see the term recausticizing, reburning, because as I told, there is a cycle. So everything is redone. It is not one time. As the chemical black liquor is coming from pulp mill, you have to generate the chemical back. So it is a cycle continuously. So how the black liquor looks for people who have not seen the black liquor also. So as you can see, is a product from Kraft process or soda process, as I mentioned. So lignin is the term I used. Lignin is bonding the cellulose material in wood or agro fiber. So that is removed, and that is what recovered as a process. So chemical recovery means recovering this lignin and back to sodium hydroxide, which is what is used in cooking. So if you keep this in mind, that is easier to understand. So the picture shows how the black liquor is taken. The pulp, when it is washed, you are able to get more and more black liquor. As you wash, make the pulp brighter, you are able to remove as much lignin as possible. So that is what it is. So you are able to see a broader process. So it is chip, pulp, washed pulp, and then bleached pulp. So you are able to see the change in color. Those are all black liquor, which is lignin, and then which is taken, as you can see, to evaporation, recovery boiler, recausticing, and back to cooking. So it is an easy process, I guess. So it is black liquor is a complex mixture, is an organic matter, which is how it is burnt into boiler. Then any chemical, which comes naturally will have some unnatural elements. So it is easy to understand again. They are called non-process elements, which are not required for the process, which will be detrimental to the process. So that is non-process elements. And then black liquor properties, uh, it is difficult in certain circumstances, especially in India, where in the northern part where we are, when agro pulping is done, silica is coming, and the black liquor is quite viscous like honey. So very difficult to handle that. Uh, in some in softwood, which is in the western countries, it is easier to handle. So there is two ends to it. So the black liquor evaporation, uh, so you give heat, then the water is evaporated, you get concentrated liquor, and then the vapor that is coming out is condensed in a multiple effect evaporator. So, so you get condensate, which can be reused. The dirty condensate can be stripped and can be reused as well. Then black liquor may have soap depending on the raw material. As I told it, if it is softwood, it will have soap, turpentine, etc. So evaporator plant is focusing on treating this cooking and bleaching effluents, as I use the term. So when you say this is effluent, I mean you have to remember this was earlier, it was otherwise going to effluent. That is what we are recovering. So and it will have this non-process element, which is chlorine, potassium. Then you can produce hot water, that is condensate. Then it will have this waste streams, which is called an concentrated non-condensable gas, which are all sulfurous gases, because the liquor is having the sulfur. So sulfur is released as you concentrate. So that can be further burnt in today's technology. And certain other this biosludge, etc., can be processed in this also. So evaporation, basically you need to give a heat transfer area in general, if you understand any heating. So where water is evaporated, so how much area you are able to give is determined by what is the volume of liquor that you have to handle and how much you have to concentrate. So this is the process. This is a simple equation which is used in the evaporation process. So to illustrate easily, it goes through the tube, and then you get black liquor with water removed, and then condensate will be used when the vapor is condensate. So this is a tubular evaporator. There are different types, of course. So we come to the multiple effect, because with one single evaporator effect, we cannot achieve the economy or the requirement. So you use multiple effects. How much effects you use, that much beneficial will be the steam that you consume. So this is very important to understand also. This is what I meant. As the number of effects increase, you are able to optimize on the steam that is given to evaporate the water. So this is simple understanding. Mostly it is about 7 effects. There are very few 8 effects evaporator also. So in a modern environment, how the evaporator looks, just to give you an idea how the evaporator train profile looks with the various effects. This is called stripper, what I meant, where the foul condensate is stripped as a clean condensate that can be used in the recausticizing process. So they have different types of evaporator that is available, which is rising, falling, film inside, film outside, forced circulation, direct contact, mechanical vapor recompression. These are all the different types for you to broadly understand. Today falling film evaporator is widely used because of some limitations to the rising film, which is a yesteryear technology. So foul condensate, as I told, can be stripped with steam or vapor, and then you in a multiple tray column, so like a reactor. So where the foul condensate, which is basically methyl mercaptans, so are taken out, and condensate is becoming pure for reuse, and the gas can be further incinerated, which is called stripper of gas. So the typical understanding of the evaporator falling film, how it looks: the liquor goes inside the tube, then steam goes outside. So anything when it interacts, there will be a film formation which is fouling the tubes. This is used in third to 7 effect in a 7 effect plant. Then so this is falling film outside tubes. This could be plate type or tube type, depending on the technology of the supplier. So this is used in first to third effect as the concentration goes further and further. So how this is called a lamella type or plate type falling film evaporator, as you can see. Now we come to the critical part of the chemical recovery, which is the recovery boiler, how the boiler functions and is doing the activity of recovering the chemical. So the heavy black liquor, which is about more than 58 to 60%, which is the minimum concentration that is required for putting into the boiler. Otherwise you will have more water, so there is a possibility of the water in contact with the smelt or the fire inside can cause explosion. So this is very important point. First important point to understand for anyone who is getting into the recovery boiler. First, safety aspect. So how the boiler looks. So basically the black liquor is given inside. green liquor is taken outside, steam is produced in a very, very simple term to understand. So basically it is recovery of chemicals and recovery of energy. So as just now I said, so the steam generation is taking place for the process steam to the mill, as well as depending on power requirement it goes to the steam generator, which is turbine. You can see the view of the recovery boiler in a mill. So what constitutes a recovery boiler? You can understand this is a modern recovery boiler for you to get a feel. You will have water, which is feed water, which goes into the boiler, and then air has to be given, which is combustion air at different levels, and then it is the steam produced is connected to the turbine, from where you can have extraction, and then the extracted that is pressure reduced steam, which is low pressure, medium pressure, can be used for the recovery boiler own process. So this is an integrated thing. How a modern recovery boiler looks and what level we are reaching. This is to give a better idea. There are boilers which are running now up to 13,000 tons dry solids. By the way, the recovery boiler is defined by tons dry solids per day of black liquor that is fired. So this is a boiler with 12,000, 110 bar 515, which is the modern day steam parameters, closer to the power boiler parameter. We are trying to, in India there is a mill in ITC Bhadrachalam. I don't know, people have come from there. So there the boiler is having high power, that is high steam pressure and temperature, 110 515. That is the first boiler. Then you can have incineration of the non-condensable gas, methanol, turpentine, biosludge and soap into this also. This evaporation, what I told, the black liquor can be concentrated up to a level of 85%. You can note down, that is the modern recovery boiler maximum concentration that is being achieved, that is in operation now. So only 15% water is remaining. When we say 85% dry solids, it is 15%, the remaining is the water. So now how it is integrated to turbine, you can see the boiler produces steam, and after the superheaters it goes to the turbine, from where the extraction takes place, and then there will be a pressure reducing station also. Good morning, sir. So the pressure reducing station will give the desired pressure to the mill usage, that is low pressure, medium pressure, etc. So the important equipments to remember is in the water and steam system, air and flue gas system, black liquor system, spouts and dissolving tank, soot blowers, electrostatic precipitator, and there are a cluster of heat exchangers. In a single slide, if we have to illustrate a recovery boiler process, this is what you can see. Everything in this has got for a modern recovery boiler. On the left side where the feed water goes into the boiler, and then combustion air goes here. Black liquor is coming into the system, which is after heating that goes inside. Then this is a dissolving tank with scrubber and vent scrubbing, um, where the chemicals are recovered. This is flue gas system with the ESP and then chimney. So you have everything in this system. Now to give you where what is there, you can get to know there are various aspects of a typical recovery boiler. For people first time who are seeing, it may look a little odd or difficult, but when you start seeing this again, this picture will be very clear what are all the integral components of this. This is another view of a closer view of the boiler with illustrating the various equipments. This the boiler pressure parts with the furnace and superheaters, this boiler bank, economizers, which are all the heat transfer area for converting water into steam process. So nothing big about it. So once you start getting into it, you will understand better. So boiler has got different process of the combustion. Black liquor is given inside and combustion air is given. Then you get a bed called char bed, which is burning mass. So from where the smelt, it goes like lava in a volcano, nothing but. So it is that temperature, it goes, and then you shatter that and then convert it as green liquor. This is high pressure steam which is generated. This is another view of closer view of the furnace, where black liquor is going through the different process of drying, devolatilized, that is volatile matters are released, then the char burning, then the upper furnace where the flue gas is carrying the dust, and then it is giving the heat transfer to the water to convert steam. This is primary air, air system, where the different components of air, primary, secondary, tertiary, sometimes it could be quaternary also. So that constitutes and different fans will be used for the required. The air will be apportioned based on the boiler black liquor chemistry. So that is the important aspect. Then what can be used in the boiler or burnt? There is a plethora of streams that can be used. Black liquor, oil, natural gas, concentrated non-condensable gas, dilute, then this dissolving tank vent gas, biosludge, soap, turpentine, methanol. There is endless. Then black liquor system, how it is handled with liquor from evaporator that is fed into the boiler through a series of equipments called ash mixing tank, pumps, heater, etc. into the furnace. So this is how black liquor is sprayed into the boiler through equipment called black liquor gun, which is spraying the most important chemical, which is the black liquor, into the furnace. Depending on black liquor characteristic, the type of gun will be different. And how smelt spout, what I explained. So you can see how the smelt is flowing like a lava inside the dissolving tank. Then the flue gas goes through the electrostatic precipitator, where through the ionization principle, some of you might be knowing, the dust is removed and flue gas as much clean as possible, that is for which it is designed, is let out to environment. Then there are safety protections in case there is any explosion in the boiler. This is called a weak corner. So this corner could be opened so that the pressure is reduced, letting out the combustion products. So when boiler is operating, there will be soot generated, obviously, the ash that is deposited. You have to clean the surface as periodically as possible, of course using steam. So this is called a soot blower. So there will be soot blowers designed for the boiler to clean the surface periodically. That is what you can remember. So this is a deaerator, which is main function is to have the feed water at the desired oxygen level. Very, very important point to note. So normally it is 7 parts per billion. That is a level of oxygen that should be there before it is let into the steam drum. So this is again deaerator function, where it is the dissolved gases are vented and oxygen level is controlled through the spray inside. Then there are many heat exchangers. This is an indirect heat exchanger, for example, for black liquor, where the black liquor, when it is evaporated, very, very important point in boiler is to not to dilute the liquor. Very, very important. In many other mills, they will heat and give steam addition directly. So that will cause dilution. So with great difficulty we are removing water, but we should not put water into the boiler. So boiler accessories, if you may see, there is a preheater, economizer as we saw, then superheaters, feed water pump. For you to remember some things when somebody is talking, what is tons dry solids per ton? What you are talking, what is dry solids of black liquor, what is density, what is high heating value, what is furnace bottom loading, steam production. So these are some terminologies that is used inside the boiler whenever you come across. How the development of boiler has taken place over a period of time. Today, as I said, 13,000 it is reached. It was way back 120, 130 years back, about 100, 120 tons dry solids. So it is 100 times more now. You can imagine the development in 100, 120 years. So next we come to the important part where we have to complete the recovery. Boiler is doing only a part function. This green liquor which is coming from the boiler is given to the recausticizing. With lime addition, you get sodium hydroxide. This is the crux of the process. So how a modern white liquor plant looks. As I told in the beginning, white liquor plant is a combination of recausticizing and lime reburning. So Please remember that term is widely used. So what are the constituents of the white liquor plant? As you can see, these are some terms that is used again in the recourse sizing. They will continuously use alkali strength. This is very important point to remember: sulfidity, alkali, etc., and cost sizing efficiency. So basic process, as I indicated, this is cycle within cycle. As you can see, um, green liquor is processed, and then lime mud is taken. Uh, Lime mud is given, which is sodium carbonate, calcium carbonate to lime kiln to produce calcium oxide, which is the main chemical. That is material chemical used in recourse sizing. So this is the typical reaction: calcium oxide, calcium hydroxide, then sodium carbonate reacts with that to produce calcium carbonate, and then in lime kiln it is dissociation, that is CaO and CO2. How the recourse sizing as a whole, the scheme looks. You can see this is a typical modern recourse sizing plant. In recourse sizing, you say what is the alkali strength, and then what is the white liquor volume that is produced, so much meter cube per day. So these two, if you keep in remembrance, so that will be very helpful. How much alkali, that is active alkali, that is produced in terms of Na2 or NaOH. So cost sizing in a modern mill, how it is there with the parameters. Today you have more than 18,000, 20,000 meter cube per day white liquor generation. Then we come to the last one, which is lime reburning. The mission is to convert the lime mud to burnt lime, which is CaO. So it is a dissociation reaction, as I told. You give heat through a burner, burning oil or other fuels which are available. Then this at higher temperature, about 900, 950 degrees, the dissociation reaction takes place, which is calcium oxide and carbonate which is released. So how typical lime reburning looks, as you can see, lime is transported once it is produced, and then flue gas is cleaned and sent to atmosphere. So there are various fuels that is used in lime kiln: gas, fuel oil, NCG, methanol, gasification gas, sawdust, pet coke, etc., as the technology improves. But typically the main fuel is fuel oil and natural gas. And nowadays lignin also is used. The lignin which is recovered is dried, and then you can get to the firing, which is important technological advancement, which is lignin separation. So then, so this is what I explained. This is dissociation reaction. How it looks, for you to get a feel how a modern lime kiln looks. This is two lime kiln together operating. Then this is a lime kiln view in night, how it looks. What are some constituents? There are some chains, different chains are there. This is a good view of how you are going through the in a cross section of the kiln with the refractory brick, and then chains which are hanging. So chains are used for the drying of or dewatering of the mud which is processed inside. This is a cooler. There are different coolers available. This is satellite cooler because it rotates like satellite around the kiln, which cools the burnt line to optimize on the heat. So secondary air goes through the kiln and then forms the combustion process. Heat is recovered. How a typical burner system of a modern lime kiln looks to give a understanding. This is the refractory because in a kiln half the weight they say is bricks and rest of the half is kiln itself. So that much importance on lime reburning. There are various castable and brick arrangements are there in the lime reburning. So the critical parameters are the kiln feed end, lime filter, moisture, burning zone temperature, oxygen control, ID fan, speed and oil flow. What are the controlling parameters? So that comes to the end. So any questions or for better understanding? Yeah, please.
Have in our mills.
You are from which mill?
Rudra Papers in Ahmedabad. Something like a bi-drum boiler or a FBC boiler.
The difference is if you go to boiler, you are able to see. So, the recovery boiler, older boilers can be bi-drum also, but this is primarily with fuel for black liquor. This is burning the black liquor is the primary importance, and steam generation is a derivative. And this is chemical recovery boiler. That is most important part of it. So, to give you differentiation between other power boiler or waste heat recovery boiler, this is a chemical recovery boiler.
Got it. So one more thing is there any other way we can treat black liquor? Any other usage of black liquor?
Black liquor, there are many usages. Dr. Saab is here. If I talk another 15 minutes, it will take. But Dr. Saab also can give a lot of ideas. Black liquor, as I told, basically lignin. Lignin, when it is extracted through different technologies that is available. I was earlier with Walmart, so I know some of the technology. So you get lignin. There are many market driven products, value added products for lignin, lignosulfonates, then the carbon black industry, then the footwear industry, even I have heard at different levels they talk, for example, pharmaceuticals, dyes. There are different applications. Today I understand about 100, 120 marketable versions of lignins are available, but the mill has to be able to extract that lignin and then sell it. In some technologies you will have to do some part evaporation. You don't have to go through the rest of the process, but once this is done, the lignin value is quite high. But in India, that technology is yet to come. To my understanding is, first is we are more conventional, and we are yet to find out a product. We are not able to sell even paper here, leave alone the lignin generated products. So that is the level we are now today as we are talking. So we have to, if we have to do a value added product, you have to do value addition. There are a lot of systems that is involved. So beyond some excess only you will be able to convert that. So today there are mills which are about 5, 6 in the world which are operating for lignin separated market products only.
Okay.
There are mills. So to that level.
Got it, sir. Thank you.
Thank you. Yes, please. Yeah.
When you use bamboo as raw material, it contains, I think, silica,
Yes,
so
correct.
it affects recovery process.
Correct. You are
why?
from which mill?
From Siripur paper mill.
Sirpur.
Yes,
correct.
sir.
So you are using some portion of bamboo, correct?
Yes, yes, sir.
Yes. That is why I wanted to touch something before coming from the office. We worked on some requirement. People who want to use 100% bamboo here. Dr. Saab will be knowing. There were mills which were operating 100% bamboo, but to my understanding, there is no mill which is now existing. There is one Kohinoor mill in Assam which is planned to start for 100% bamboo, but yet to come. There are only some portion. The primary reason, as you touched, silica level is high. So you need to put a lot of washing. They call chip washer, if I may say correctly. So you have to remove the silica to that level, and there are you know, in Assam, Hindustan paper, Naugan, Kachar, which are closed today, government mills, they were originally started with 100% bamboo, but substituted with wood. So 100% JK CPM is another mill. To my understanding, that was operated initially, but they have converted now to conventional wood and maybe small. Orient paper is using little bit, but there is, having said that, in China there are 100% bamboo based mills are available. In India it has become less because the mill size is less, and silica is a problem. Again, from northeast part of India, bamboo quality will be totally different from as you traverse across the west. So that is also what I understand, the silica level and the properties of bamboo. So these are some reasons. Anything more you want, I can tell.
Okay, thank you, sir.
Any more questions? Exactly. I will touch 2 bullet points. Thank you for. You are from which mill? Sri Shakti Papers. And you are in which department? Commercial. Beautifully put. Thanks for reminding many of the people who are here, who are also connected to recovery. I will touch 2-3 important points. Recovery boiler, by life, you can say about 30-35 years normally. Normally is the key word. Having said that, there are mills which are selling off some 20-25 years boiler, going to a latest technology like that. There are boilers which are used for 40 years also. So like that, who are trying to prolong that sort of situation. Second most important question is, this is called life cycle management or residual life assessment. My colleague has come here from NMAS also. He is into this residual life assessment. This is also called, you may note down, this is a modern terminology, asset management. In Western parlance, this is called asset management. So how you maintain your asset? In the chemical recovery, within a mill, recovery boiler is the biggest asset. So how you maintain? Annual maintenance is the most important part of it. There are mills which are doing that There are mills which are not doing this, who may do some portion, may go very quick on production, because production will be very important. Like our body, we go for how the annual maintenance of human being has come into picture. Same thing, how much we are discarding, same effect will be there in this asset also. I think the best answer I could give, it is that much. If you don't do any asset management of your own body, it may reveal without telling you also, and there is no looking back. So same thing, the best way is to do annual maintenance whenever there is opportunity. Of course, there are boilers which are not able to run more than 3-4 months in a difficult environment. So you do the important maintenance. There are certain areas, if somebody is interested, I can tell what important area that boiler has to be looked at. Is another detailed discussion. So important point is this asset management has to be done every year. Very, very important. Any more question?